this we have discussed in the last slide, the conductivity of period 3 elements. Okay, that this this is about your bonding and about the structure. Have we discussed this in the last class? Tell me.
Yes, we did.
Okay, now explanation here is written that sodium, magnesium and aluminium, they are at the start of period 3. Okay, they are all metallic elements. They are metallic. How to define metallic bonding? We have discussed it in chemical bonding chapter also. That positive ions are there. They are arranged in a giant lattice held together by a sea of delocalized electrons. So this is the definition of metallic bonding. Delocalized electrons are those from the outermost valence shell. Okay, they are the delocalized electrons which are in the valence shell, outermost shell. So delocalized electrons, they are free to move around within the structure of metal, and that's why your conductivity happens in the metals. When a potential difference is applied, the delocalized electrons, they drift through the metal towards the positive terminal. Both the melting point and the electrical conductivity increase from sodium to magnesium to aluminium, right? Because they are metals. How you can explain this? By the number of electrons each metal donates into the sea of delocalized electrons in the crystal structure and the increasing charge on the metal ions in the giant metallic lattice. Okay, for example, sodium is +1, magnesium has +2, aluminium has +3. Okay, so number of charge is also increasing. Each sodium atom, it donates just 1 electron, it forms Na plus ion. Aluminium atom donates 3 electrons, forming Al3 plus ion. So this is clear from the electronic configuration. This makes the metallic bonding in aluminium stronger because of the electrostatic forces of attraction between its 3 positive ions and the larger number of delocalized electrons, negatively charged delocalized electrons, which are holding the giant structure together. So they are stronger in case of aluminium. There are also more delocalized electrons which are available to drift through the structure when aluminium metal conducts an electric current. So aluminium is a better electrical conductor as compared to sodium. So the reason here are written here that the charges increase, number of electrons increases here, okay, and the charge is also increasing. So aluminium, it is a better electrical conductor as compared to sodium. Clear? So this you have to learn it, write it down.
Okay. I'm done.
The change in melting point across a period, it reflects the type of structure and bonding. Okay, the melting point is reflected by which bonding it follows. So as we go across a period, metals have increasingly strong metallic bonding. Okay, as we have seen that aluminium have a greater metallic bonding as compared to magnesium and sodium. As we move across a period, we are talking about period 3 elements only now. So their melting points will increase because of metallic bonding will increase. So melting point also increase. In period 2 and period 3, the group 14 elements, they have giant covalent structures. So there are some things which we have already studied in chemical bonding part. That group 14 elements, they have giant covalent structures. So it is very hard to break them. Okay, so they have very high melting. Then again, from 15 to 18, most of the elements, they are non-metals. So they have simple molecular structures and they are easy to break. So they have relatively low melting point. So see the trend. First, if we are moving across the period, then we have a higher melting point. Then 14 elements will come. Then we have a high melting point, okay, because they have giant covalent structures, very high melting point in fact. Then from 15 to 18, they are non-metals, so they have simple molecular structures, so they have the relatively low melting. Is it clear?
Yes.
Write it down.
I'm done.
The element in the center of period 3, that is silicon, has the highest melting point. So this question may come in MCQ based, that which element in period 3 have highest melting point? It is silicon. Why? Because of its giant molecular structure. Okay. So the structure, you know that every silicon atom is held to its neighboring silicon atom by strong covalent bonds. If we talk about its electrical conductivity, it is much lower than the metals at the start of the period. That means it is electrical conductivity is lesser as compared to sodium, magnesium and aluminium, because here there are no delocalized electrons which are free. Silicon comes after carbon, below carbon, okay, and carbon it makes all the four valencies of carbon are filled, right? So there are no delocalized electrons to move around within its structure. So if there are no delocalized electrons, then electrical conductivity is very less, okay, or no electrical conductivity. Here there's insulator. So silicon is classified as your semi-metal or metalloid. Metalloid is semi-metal and semi-metal is metalloid. Okay.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So which is the metalloid in the group 3? Sorry, which is the what is the name of the element which is metalloid in the period 3? So the answer is silicon. So this is all theoretical part. You just have to remember these things. Write it down.
I'm done.
Then moving to the elements to the right of the silicon, then they are all non-metallic elements. Okay, phosphorus, sulfur, chlorine, they are all non-metallic elements. They exist as relatively small molecules. Sulfur exists as S8. Okay, this S8 is your the substance like this. Phosphorus exists as P4. So this is the stable form of these elements. And chlorine, you know, it is a gas which exists as Cl2 molecule. Although covalent bonds within each molecule are strong, so this we have studied in chemical bonding that covalent bonds within each molecule are strong, but still there are relatively weak ID forces between their molecules. Okay, instantaneous dipole, reduced dipole forces are there between their molecules. Temporary forces there are. So it does not take much energy to break these weak intermolecular forces and melt the element. That's why they have low melting points. So phosphorus and sulfur are solid at room temperature we are talking about. So they have low melting point and chlorine is itself a gas at room temperature. Now, if we come to the last element, argon, of the third period, then it exists as single atoms. Okay, argon only exists as AR with very weak instantaneous ID forces between these atoms. It's a normal gas. Okay, it's an inert gas, so it has very weak instantaneous dipole, induced dipole forces because it exists as a single atom. It is very unreactive. Okay,
Okay.
write it down.
I'm done.
Questions are your questions. I think you can easily solve. These are theoretical questions. Why does sulfur have a lower melting point than silicon? Why does sulfur have a higher melting point than chlorine? Why is magnesium better electrical conductor than phosphorus and sodium?
Done.
Okay, now we are going to learn about the reactions of period 3 elements with oxygen. So we'll study all the elements. Like first we'll study sodium, starting from the sodium. It reacts vigorously when heated and placed in a gas jar of oxygen. So the sodium burns with a bright yellow flame, and the main product when sodium burns in a limited amount of oxygen is a white solid sodium oxide. So this sodium oxide is white colored solid. Write it down.
I'm done.
Next reaction we'll study with magnesium. Magnesium also reacts vigorously when heated in oxygen. So it forms magnesium oxide, MgO. Aluminium metal is protected by a layer of aluminium oxide, Al2O3. But powdered aluminium, it does react well with the oxygen. So both metals burn with bright white flame. Okay. So the product, remember, for sodium it is Na2O, for magnesium it is MgO, and for aluminium it is Al2O. Write down.
I'm done.
Study the silicon reaction. Silicon, it reacts slowly with oxygen to form the silicon dioxide. This reaction is slowly, but all the other previous three reactions, they are vigorous. So the product is silicon dioxide. Phosphorus, it reacts vigorously again with oxygen. So yellow or white flame is seen and clouds of white phosphorus oxide are formed. So when phosphorus reacts with oxygen, you have phosphorus oxide. It is also written as P2O5. Okay, so it is phosphorus pentoxide. So this is the reaction with silicon and phosphorus with oxygen. Okay, so let's end the session here. Only in the next class we'll study the reactions with sulfur, chlorine, and argon. Obviously, it is unreactive, so it doesn't react.